And then array. Let's see, where are we? Good. Thank you, Warren, and also thanks to Robin for bringing me here. And very honored to be following Jesse. And definitely took a lot of good notes. Maybe I think in the context of maybe boxing, I will maybe contrast our fighting style towards the end of this. In any case, I'll just jump in right now. This is actually, I'm just going to tell you kind of a story of kind of how we got to doing what we're currently doing. And it kind of starts over here in this building that's pictured here. And this is Stanford University Center for Computer Research in Music and Acoustics at CCRMA, and it's pronounced Karma. This is one of the two places where I work. The other is Smule. And this is kind of a nexus of computer music research where computer science, music, electrical engineering, psychology kind of all come together. And it's really kind of working on things here and other places in the computer music research community that really led to some of the things we are looking at today. But backing up, a couple of decades, this is the IBM 360, and computers actually have been fairly, always attractive as long as there's been the notion of computing of music and sound, due to the precision, programmability, and I think that their potential for fantastical automations. And certainly the IBM 360, this machine is, I think, older than I am, is something that people have used for actually making sound. But I think of this less as a computer, but more as, as a kitchen, where you can actually take raw ingredients and actually build up the dish or the sound in exactly the way that you want. So in grad school, I worked on a programming language called Chuck, which is a sound synthesis language that you can use to make music. And I'm just going to actually give you a quick demo of this right now, or attempt to. So this is some Chuck code. If you don't know what this means, do not worry. What I'm going to do here is that Chuck is actually less about kind of what you can program, more about how you can program it. It's about the psychology, perhaps, of actually writing audio programs. So what we have here is actually a program that takes a sine wave, has a set of pitches we're going to choose from, randomly draws from a bag of different pitches, and plays them every so often. And at the onset, it sounds something like this. And that's because we only have one pitch here. What I'm going to start doing here is to actually, on the fly, change this program, and then start exploring what this music can be like. So I'm going to add a major second here. And every time you see an equal sign, I'm actually replacing the previous version of the code with a new version. Add a major third. Let's go ahead and add a perfect fifth. Let's make this a little faster. And that sounds kind of nice, but I bet it sounds even better with some reverb. So add reverb here. Shift this up by a couple of registers. Add a major sixth, major seventh. Make this even faster. Drop this to minor, for example. And here's a way of actually rapidly prototyping sound and music, one line of code at a time. We're actually thinking the programming language less as a tool, but more as a user interface. And this is the kind of stuff I was working on, but I think that the theme that I think I've been trying to really work with is one that straddles between technology, people, and psychology. And it's really, I call it sometimes the aesthetics of design, or some refer to it as computational aesthetics, perhaps in other contexts. Something else that's another raw ingredient, and what I want to talk about is the laptop orchestra. The picture here is the Princeton Laptop Orchestra for Plurk. This is started by music professor Dan Truman and my advisor at Princeton, Perry Cook. And this is actually making a large ensemble of laptops, people, and special hemispherical speaker arrays. These are actually speaker arrays we built at the Stanford Laptop Orchestra, SLORC. We actually built these out of IKEA salad bowls. And the idea here is that we want to use computers to make instruments, but use these to make them sound more like traditional acoustic instruments. So the idea is that you play like a violin. The sound doesn't go through a PA system and comes out around you. It comes from the artifact. These are meant to give each laptop its own kind of sonic sphere. And certainly at Stanford, Slope of a lot of laptops, and when you put people, laptops, and these speakers together, you have the beginnings of an ensemble. And we use a lot of different interfaces, and we create music and instruments and performances kind of from the ground up. And so let's give you a quick demo here if I can. So this is just a kind of a gaming joystick, something you might get. I think that was like $20 at like something like CompUSA. And you can see this. But basically, when I squeeze the trigger here, this is actually going to a Schell program that's generating. That's actually generating. Wow, it's really much clearer. Thank you. This sings the sound. Now that's not a full anyone. It's not a real person singing. It's also not a recorded sound. It's the computer actually generating this from scratch. And it sounds very synthetic. But then using various parts of this joystick, we make it more expressive by being able to control it expressively. So by tilting it to different parts, we actually hear it sing different vowels. And it will do so smoothly. It's kind of like gently grabbing someone by the throat and shaking it. If you turn this, you get a little bit of vibrato. It's a computer model, so what you can do then is to make, instead of sing, you can make it breathe. And then I'm going to turn it back to singing mode, and I'm going to actually pair it with the laptop keyboard to actually make another instrument. So I just press the keys, Z, C, B, A, D, G, W, E. It's kind of like I sing kind of low, or pretty high. It sounds, kind of crazy. And you can play little ditties with this. So let's see. For example. So that's just one of like hundreds of instruments we've created just using commodity computers and just parts that we can find in the world around us. A lot of them are gaming devices. And the more we work with this, the more we kind of find a lot of resonance with this what Ben Schneiderman, an HCI researcher, says, that the old computing is about what computers can do, whereas the new computing is about what people can do. And I think this is really the shift that we're continuing to experience between focus on technology only to focusing on technology informed by psychology. And it's with all these ingredients that we, and also I think a bout of insanity, that I co-founded Smule with Jeff Smith and others in the summer of 2008. And here's to explore music making for people on the iPhone and other mobile devices. So my first app, actually, ironically, is actually not a musical instrument, but a sound-related one. And I'll demo that for you here. It's actually called Sonic Lighter. And let's see, I'm just going to go here. I'm going to turn on the Sonic Lighter right here. Let's see. And zoom in. Okay, so this is your kind of standard fair lighter on your iPhone. And you can run your finger through it if you want. You can use multi-touch to make the flame larger or smaller. It responds to accelerometer. So you can, do this with it at concerts. It's actually the original inspiration for this, you can call it that. But this is where I think the similarities stop. And this is something about designing for this that we've at least tried to experiment with. And that is to treat this not as a virtual thing, but rather, we're trying to say, this is not a simulation of a lighter. The iPhone is your lighter. And we try to prove this in a couple of different ways. One, if you turn this too far, like this, I'm sure you can see this. Here we go. The flame is actually burning the side of my phone. And there's actually, if you're close enough, you can hear a sickening crackling sound. That's just the sound of my iPhone getting singed. And another, perhaps slightly more poetic physical gesture is one of actually blowing into the phone. So I can blow out the flame. Let me do that again. For example. So this is actually, the latter is actually done with sound. Blowing into the microphone. This is a Chuck script running inside that's actually modulating the flames if it detects that the volume level gets too high and then extinguishes the flame. Something else we're doing with sound here. Let's have 2 sonic gliders here. And I'm going to just turn on one of them. And I'm going to throw it into flamethrower mode. It lights the other. And you can really hear this, but there's actually just a tiny little sound that's emitted. We call it a sonic modem. And this near-field communication is getting picked up by this other phone, which is another Chuck script running, listening for this tone. Once it hears it, then it's like, oh, someone's trying to ignite me, I'm going to burst into flames. So, and finally, there's a social feature to this. And that's actually the beginning. If you haven't used any Smule products, you might notice there's always a globe. Well, this is the first time the globe actually appeared in one of our products. It's our first product. And it came out rather accidentally. It came as a result of someone asking me, so what should David work on? David being our director of engineering. I was like, I don't know, let's make a globe and just plot where other users are using their sonic gliders. And that turned out to be interesting in that it's kind of a social interaction that's very anonymous. If nothing else, this is trying to provide a tinge of connection to you with other people who have also spent $1 to buy a fake lighter on their iPhone. And somehow it's maybe it's just that little connection. But it's still meaningful, we would argue. So it's actually the first 7 days of ignition. And really thinking about the technology, it's got us thinking about the iPhone. And this quote keeps coming back to mind. This is that ageless golden quote from science fiction author Arthur C. Clarke, is that any sufficiently advanced technology is indistinguishable from magic. And I think in designing, I think the best technologies are the ones that are magical, in the sense that you don't need to know how they work in order to really derive some unique goodness from it. I think airplanes and automobiles are really good examples of that, perhaps. And so we went on to really try to design around this philosophy that this device is a physical thing and to try to provide a sense of magic. And what we ended up working on next is actually an app called Octerina. And Octerina was really kind of an experiment in trying to use everything we can on the iPhone. Multi-touch, microphone input, speaker output, accelerometer, location, sound synthesis, as well as the persistent network connection that's there. So I'm going to give you just a quick demo here. So actually all the ingredients here was in some ways already present in the sonic glider. We just kind of made it into kind of an instrument. So vibrato is controlled by actually tilting the phone. So you kind of get that instant just add water type of expressiveness with that. And so I'm trying to play a little ditty here. And nice. This is kind of the digital Octerina, and the idea here is, in terms of design, is something we call inside-out design. And the idea there is that instead of thinking about, okay, what's a good thing to kind of port to a mobile device? What's a good instrument or musical experience? Instead, think about the device first and kind of go outward from there and say, what is this good for? And so, when thinking about the form factor and what the iPhone supported, it seems like in size and in functionality, it's something that we can easily make an ocarina out of. And it was really kind of from the iPhone that we designed the ocarina. It wasn't like we wanted to make an ocarina and the iPhone happened to be a good thing for it. I think it was better for another instrument. We probably would have tried to make that instrument. There's actually another social aspect to ocarina. And in this one is the same globe, but on this globe, you're actually hearing other people around the world play their iPhone ocarinas. This is a very minimal piece by Ipsa, coming from, looks like Chicago. Mo Johnson from, I don't know.
Understand, this is happening in real time.
Here's Duno.
These people are doing this right now.
That's, I'm going to censor that one. And so someone coming from Europe. And so the idea here is that you don't know who these people are, but you know that they're actually blowing into their iPhones to make music. And to date, some 40 million people have actually listened to just some 40 million different times on the ocarina. And so this is actually something that people are doing. In fact, we've gotten all kinds of anecdotes of people, they said, well, we wish I had dinners where we just kind of left the ocarina on the globe on the dinner table. And this is our dinner entertainment.
So, Jesse, do you have people doing stuff that cool over at Carnegie Mellon?
I don't know.
Something like a knockout punch there.
I'm sure we'll come back.
So let me actually stop that there. And actually our users have really gone wild with this. To date, Octerina has been downloaded close to 5 million times. And users have created like thousands of YouTube videos. Just, this is actually like, it's not something we planned for at all. And I'll just show you a couple of them. By the way, they're actually looking on our website. This is how they're learning this. This is Ocarina tablature. And it's also a community of Ocarina users who actually generate these on the website. And these are very simple to follow. Even if you've never played music or know how to read music, in about, I think, 10 seconds, you can kind of figure this out. This is actually how you're supposed to, hold down, which finger holes to hold down, which ones to light up. And arrows just means just hold that note for kind of, a little while. If you know the melody, this would be pretty easy. And also our users have amazed us with their virtuosity. So this is one of our winners from the This Contest Blows Ocarina video.
I think I would have hugged somebody.
She's very good, and I hear like an ocarina, that's still playing. So that's actually that device. Here's a rather unexpected use, and another winner in our contest. So yeah, she's playing music of the night through her nose. Yeah, she's another winner in our contest. There are 15 winners. We send each of them $1,000, a Smule t-shirt. Just for her, we send her a box of Kleenex. The next thing we did was lead trombone.
Okay, illicit use of humor.
Thank you, Warren. And the next thing we did is lead trombone world stage. And this is a follow-up to Ocarina, but it made lead trombone kind of a game that's very self-contained. The Ocarina, unless you already knew the melody, you had to go online and play it, which is kind of nice. It's kind of like learning the recorder, and your computer screen became kind of your score and your music stand. In this case, we're trying to make it kind of self-contained, and you blow into the phone, but then there are little marks that tell you where to position the trombone slide and when to blow into this. So it's kind of like a Guitar Hero in that way, but I think I'll make one distinction. And the distinction is that I think, wow, that sounds good. Just like beautiful. beautiful ocarina music happening by random. It's really cool.
Okay, stop that.
Yeah, you're not allowed to have fun in the middle of these presentations.
No.
It's kids that play. You're not kids.
Yeah, what's that about?
So,
We do have cards.
actually, I encourage all of you to download Octerina right now if you haven't already, and start playing.
Okay, that's a sales pitch.
So,
If my kids did this, I'm telling you. I'm just kidding.
I think on Rock Band and Guitar Hero, I think those are games before they're instruments. And I think they're successful because they're very cleverly masquerade games as instruments. I think we try to build the opposite. We try to build an instrument that's expressive, and make a game, put game-like elements on top of it to, I think, drive the inhibition down of actually wanting to actually do this in the first place. And I think that's a big part of what we're trying to get at, is that just, this idea that we have this belief that everyone is inherently creative, and not everyone believes that's the case. And it's just trying to make everyone at least forget about that and actually just start doing it. And in the process, they discover, oh, I can do this. And leaf trombone is kind of another one of these instances. But this one had an interesting social component, and we called it the world stage. I'm just going to demonstrate it here on the iPad if I can. I'm going to observe a performance that has already happened. And the idea of the world stage is a kind of, you might think of it as a crowdsourcing metaphor for performance and music critiquing. So I'm going to observe, we've already favored this, and let's see, so we're going to observe basically a performer getting judged by three judges in real time. 3 judges actually judging this relative to each other in real time, and these are actually our users basically critiquing each other. And this is kind of what it looks like. And these are actually real users. This is session number 545,704. So a lot of judging sessions have gone down.
Just to be clear, this is real time.
So you can see the emoticons. This person is giving the thumbs up. And this is one of several ways. That one's got his sonic glider out. That's a pretty epic song, so these guys are really getting into it. Everyone's got their gliders out now.
I'm starting to feel better.
And you can also do text comments. But we felt emoticons is kind of the most direct way. And by the way, we had to censor it. The app automatically censors when they get too excited. I assume that's a really positive comment. At the end of the performance, each judge actually gives the performer kind of a score based on from 1 to 10. And that is actually fed back to the performer, who can view this all the time and rock it out. So you can see kind of the score right here.
And I have to keep the agenda somewhat on track. So can we get, well, keep going.
Okay, I'll try to.
Yeah.
So I'll skip over the part about the Stanford Mobile Phone Orchestra, except to say it exists, and it has a horrible name called MoFo. We work speakers on gloves, and then in the meantime, actually in the Smule world, T-Pain has been using our products, unbeknownst to us, before we got in touch with them. We did get in touch with them to make an app together, and that turned out to be I Am T-Pain. And at the risk of completely embarrassing myself further, I'm going to try to sing for you here a little bit through I Am T-Pain. Basically, this is T-Pain's idea, and unlike most of our apps, which we conceptualize, this one T-Pain said, we said to T-Pain, we want to make an app that, captures some of the essence of who you are as an artist. And he said, well, just put auto-tune on the iPhone. Yeah. And we're like, oh, that's a good idea. Let's do that. So I'm going to attempt to sing for you.
You want Jesse to try it?
Do you know how to sing Buy You a Drink?
No.
I'd kind of like to see that, frankly.
That's a punch.
Jesse, this is working. This is working.
What's back on the agenda? I'm T-Pain, you know me. Come with music, what's the chance you're rolling with me? So. I'll wrap up here and to talk about kind of the iPad apps, and maybe I won't demo these. And so the Magic Piano and Magic Fiddle are actually our latest offering, and these are actually made for the iPad. And I think the idea here is actually to build experiences that, well, you know what? I think this is in the beginning. I said I'll kind of contrast our fighting styles. Between what Jesse said and what how we do it, I think Jesse seems really great and insightful about designing for kids and parents. We, on the other hand, don't know what we're doing, and so I think that's really one contrast.
You went straight for the ear.
Yes, I'm gonna bite off the other ear pretty soon, and but I think if I may try to articulate what we think we're doing is that instead of designing necessarily directly for kids, we're designing for the kids in everyone, including kids and adults. And this is why Magic Piano we've seen videos of 2-week-old infants pounding on it to 90-year-old, grandmas who've never used a computer in their life, and who have actually, some have stories of them someone said, I've always wanted to play piano. I feel like I can. This is actually the same comment we hear from 4-year-olds as we might, or 7-year-olds, and we might from 90-year-olds. And also cats are learning to play the iPad. So at the end of the day, I think riding on the magic of the technology we have today, I think we really want to try to further capture the magic from music. And so that's, I think, the psychology part of this. And through things like, we have other experiences like Glee Karaoke, which allows you to collaboratively sing with other people around the world, to Magic Fiddle, which teaches you how to play the fiddle. In fact, the fiddle talks to you, kind of like Kit. The fiddle is more like a slightly more, like, I would say malignant force. Maybe not malignant, it's a nice force, but it's more like HAL 9000 from 2001, but it says hello on your fiddle, and it tries to derive its personality, and it teaches you how to play Magic Fiddle. And so I think I'll just sum up here and just say, in designing for this, there's all these different ways we look at how mobile devices relate to laptops, both of which we work with. But I think the biggest point is that they're fundamentally different and deserve their own design space. And I'll end with this quote by Mark Weiser, who 20 years ago had his paper on computers for the 21st century, and essentially predicted much of what's happening. He said ubiquitous computing, and he's one of the people that coined this, names the third wave in computing now just beginning. First were mainframes, shared by a lot of people. We're now in the age of personal computing, where machine and human stare uneasily at each other across the desktop. Next comes the age of ubiquitous computing, or the era or the age of what he called calm technology. Technology that recedes into the background of our lives. And I think this is really kind of what's happening here with mobile. It's not the fact that they're mobile, that you can take them to the airport, to the jungle, to wherever. It's the fact that it's pervasive, ubiquitous, and that instead of actually going to the computer to compute, we're bringing computing back out into our everyday life and our everyday into our everyday world. And we really want to design for that. And I think there's, in some sense, we're trying to design things that need no manuals, where I think kids and non-kids alike can pick them up and start exploring with them. And before they know it, and that's really part of the trick, they're making music. And once that happens, I think it's much easier to get them to continue making music. So I'll end with this quote: "The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they're indistinguishable from them." With that, I thank you very much.
Thank you. Thank you.
I'd
like to, we've judged them, and I'd like to determine the winner here. If you guys could just put your hands up and just say, you both win. Actually, the audience wins. Yeah.